Of all the major biogeochemical cycles on Earth, perhaps one of the most useful is the carbon cycle. It is responsible for most of our natural resource needs, be it food, fossil fuels, construction material, clothing, and you name it. So, where is all this carbon stored? Research estimates that at least 65,500 billion tons are stored in rocks, while the rest is in the oceans in the form of sediments and ions, in the atmosphere in the gaseous oxide form, in plants and soil as organic matter, and in fossil fuels in the form of coal, petroleum, and natural gas. The carbon cycle is the cycling of this carbon from the various reservoirs on Earth, which has a major function, that is, maintaining balance in the Earth's temperature, much like a thermostat. Ice core data suggests that there has been a fluctuation in the Earth's temperature along with the changes in the atmosphere carbon dioxide amounts, leading to periods of glaciations and global warmings. Ice core data measures the ratio of the 18O, that is the heavier isotope of oxygen in water, where a warmer atmosphere would mean less percentage of 18O as it is heavier, so less evaporation, and a colder atmosphere would mean a greater percentage of 18O. This figure shows the amounts of carbon released and absorbed through the various processes. Photosynthesis by green plants and phytoplanktons absorb a lot of carbon dioxide into the earth. And natural processes like volcanic eruptions release a lot of carbon dioxide back into the atmosphere along with respiration by all living organisms. Human emissions are a major chunk of emission sources in the recent past and has been the major reason for increasing CO2 levels in the atmosphere. Within the carbon cycle, there are two parallel cycles going on. One is the slow carbon cycle, and the other one is the fast carbon cycle. So, the slow carbon cycle is basically a series of chemical reactions and tectonic activity that take at least 100 to 200 million years to cycle between the various reservoirs. The carbon moves from atmosphere to lithosphere in the form of acid rain, carbonic acid, which is basically rainwater dissolved with CO2, which is in the atmosphere. It causes weathering of rocks. Weathering of rocks releases calcium, magnesium, sodium, potassium ions that are carried into rivers, and these rivers eventually drain into the oceans. The calcium ions thereby combines with the bicarbonate ions that forms calcium carbonate. Calcium carbonate, as you all know, is an important constituent of the shells of the aquatic organisms. So these shells, as well as the dead remains of these calcifying organisms and skeletons, they cement in the ocean bottoms to form limestone. And this process creates at least 80% of our carbon containing rocks, while rest of the rocks come from the dead remains of organisms, that is through the process of organic carbon. That is how coal, petroleum, and such other rocks are formed. And the release pathway of this slow carbon cycle is through volcanism or volcanic activity. The sedimentary rock limestone is made up of the calcium carbonate that is contained in the skeletons of the marine organisms which get deposited and create such rocks. And coal, as you all know, stores carbon that on combustion also releases it back to the atmosphere, and it is also made up of dead and decaying organisms that compact over the years. The fast carbon cycle is much more rapid, primarily aided by the green plants and phytoplanktons that use the atmospheric carbon dioxide to create simple sugars and oxygen using sunlight through the process of photosynthesis. These simple sugars are used up by the plants and by the consumers to continue the energy flow through the food chain, and it gets released back into the atmosphere through the process of decomposition by the decomposers and through respiration by all of these organisms. There has been a flux or variation in the Earth's carbon cycle, as suggested by historical ice core data analysis, and the rise in the Earth's temperature can be linked to the rise in carbon emissions. The present scenario is a little different, as for the first time in the history of the Earth, human beings are responsible for this change due to the increase in carbon emissions. We see a gradual shift from a slow carbon cycle to a faster carbon cycle. It has been seen that at least 39% of carbon dioxide has increased since the start of the Industrial Revolution. Carbon dioxide is also responsible for 20% of greenhouse effect on Earth. Water vapor is responsible for 50%, and another 25% is the responsibility of clouds. But it has been seen that water evaporation is in turn influenced by carbon dioxide. So, more carbon dioxide would mean more evaporation of water. So, the 20% carbon dioxide's responsibility for greenhouse effect is actually a lot. The pH of the ocean surfaces has seen to drop by 0.1 in the pH scale, which is about 30% change in ocean salinity, and it is leading to, as you all know, ocean acidification. And more ocean acidification would lead to death of all the organisms that have calcium carbonate in their exoskeletons. A warmer temperature is also leading to the thawing of the organic carbon stocks in the northern hemisphere in the permafrost regions. And this thawing could gradually also release even more organic carbon into the atmosphere. Thus, in the present scenario, the carbon cycle is a great necessity to understand climate change and global warming even better. Thank you.